Hi everybody, it's Mrs. Dinkelman again. This is the AB review, just kind of getting us reviewing some of the integrals, since that's kind of where we left off last year, or it kind of happened at the end of the year. So I want to make sure that we're good to go before we move along to some BC topics. So I thought it'd be helpful to think about the derivatives first, and then just to perhaps have a derivative table in your notes somewhere. So that's what we're going to go through here. So this first one is just kind of reminding us about the power rule. So when we drop down the exponent and then we subtract 1 from the exponent, derivative of e to the x is e to the x, and then the derivative of natural log of x is 1 over x. I'm going to go ahead and go over to our trig next. Derivative of sine is cosine. Derivative of cosine is negative sine. Just a quick reminder, the way I remember this is that the derivative of every cofunction, so this one, and this one, all of those will have negative derivatives. Derivative of tangent is secant squared. Derivative of cosecant is negative cosecant cotangent. Derivative of secant is secant tangent. Derivative of cotangent is negative cosecant squared. Okay. And then if we go to the trig inverses, so we're going to see these occur a little bit more in BC than you might have in AB. I know that we didn't get to take that exact AP test, but they do occur quite a bit more, especially tan inverse. So just a quick reminder that the derivative of sine inverse is 1 over the square root of 1 minus x squared. And then cosine is just the negative version of that. So a lot of times you'll just see sine. Sorry, my writing is struggling because that thing is shifting. Anyhow, so it's just the negative version of that. So negative 1 over the square root of 1 minus x squared. And this is the one we're going to see a lot more often, 1 over 1 plus x squared. Now these last two are something that we hardly ever see, but just in case, we want to make sure we have these. So the derivative of a to the x is really similar to a to the x, but then we're also going to have ln of a. And this technically applies to the to e to the x. It's just that ln of e is 1. Okay, and I have to remind myself for this one, we're going to have 1 over x, and then also, I have to think about this one. We rarely ever see that one, and you can tell by the way that I'm hesitating with it. Here's what I'm going to do real quick. I'm going to write myself a proof for what the derivative is so that you can see if you get stuck like I am really quick that you'll have it. So remember that log base a of x, we could use a change of base formula. And now I already see what it is. It's natural log of x divided by ln of a. That's just the change of base formula. So we can think of this as 1 over ln of a times natural log of x. So 1 over ln a, remember, is just a constant. And then we have the derivative here would be 1 over x. So we're just going to have an ln of a down here. So that's a way, if you've forgotten where that natural log goes, that you can remember as well. Okay, so now to antiderivatives, just to talk about a few of these, and a lot of them are just really similar in reverse of what we just talked about, but just kind of getting ourselves in that mind frame. So for the antiderivative of x to the n, remember what's going to happen, and what I say aloud to myself a lot is we're going to add 1 to the exponent, and we're going to divide by the new exponent. So x to the n plus 1 divided by n plus 1. Antiderivative of e to the x is e to the x. If we see a 1 over x to the 1, or even if this x has like a minus 3, then we know we have natural log. Now, normally we put, I should be putting plus c's. We should be putting absolute values here because we don't know if there's a domain restriction. So let's go ahead and make sure, don't forget to add the plus c there. Normally when we see this 1 over the square root of 1 minus x squared, we're just going to think sine inverse. And even if it was negative, a lot of times you'll see that they just have negative sine inverse there for that answer. And then this one is our tan inverse. That's the one we're going to see a lot more in BC this year. We have to be careful with the sines and cosines as we think backwards. So some people just want to say cosine, and I'm already remembering I forgot to put plus c on those other ones. Oops. There we go. Plus c, plus c. There, did it sneak in there? Okay, so we can't just put cosine here because remember the derivative of cosine would be negative sine, and that's not what's here. So we're going to have to add the little negative there. With sine, it's okay because the derivative of sine is cosine. When we see a secant squared, we want to remember that that's tangent. Cosecant, cotangent. Now remember that the derivative of cosecant is negative cosecant cotangent, so we're going to have a negative here because that one doesn't have one. Derivative of secant is secant tangent. And then the derivative of cotangent is negative cosecant squared, but again, we don't have a negative, so there's a negative. So on this one for your assignment, it's just kind of doing all sorts of different integrals just for practice to make sure we got a hold of what we're doing before we move on to some other techniques.